NASA discovering a new planet
way out there in space. It looks rocky and is nearly the same size as Earth.
Something amazing just happened. NASA's James Webb Space Telescope has confirmed a rocky planet beyond our solar system for the first time ever. This long-awaited discovery could lead to many more, as the telescope slowly unveils the mysteries of space. In this video, we'll explore how the Webb data obtained from the two transits combined into one transmission spectrum were used to gain insight into the planet's size and atmosphere. Make sure to watch till the end to find out what this could mean for the future of space exploration. So without wasting any more time, let's dive in and explore. We're all excited to be witnessing a breakthrough in the confirmation of a rocky planet outside our solar system. Thanks to observations by NASA's James Webb Space Telescope, scientists were able to precisely measure the size and density of an exoplanet known as LHS 475b. This exciting discovery has set the stage for further research into planets beyond our own solar system and a closer examination of this mysterious new world. The data gleaned from this initial exploration could shed light on what these distant planets look like and give us clues about the conditions that their atmospheres have created. With more groundbreaking discoveries from Webb within reach, it's likely we'll discover even more secrets hidden in deep space. Using transits to measure an exoplanet is a complex method and needs high accuracy with accurate time management. A transit is when a celestial object passes in front of its star, blocking some of the light from the star. This reduces the amount of light that reaches Earth and can be measured by telescopes such as James Webb. By measuring this reduction in brightness during each transit, astronomers can learn more about the object passing in front of its host star. This method has been used to identify exoplanets, planets outside our solar system, by investigating changes in brightness caused by transits. In addition to confirming the existence of rocky planets like LHS 475b, this technique allows us to measure parameters such as their size, density, and distance from their host stars. Thanks to James Webb's powerful telescope, we've taken another step towards understanding our universe and the amazing objects that exist beyond our own. Kevin Ortiz Ceballos, a student at the Harvard-Smithsonian Center for Astrophysics in Massachusetts, who performed the data analyses, had an incredibly positive outlook on the findings of Webb's data. In a statement, he said that the telescope is so sensitive and precise that they could have easily detected several different molecules if they were present, but they don't see much yet. He remained hopeful for future discoveries from Webb, as it has made this rocky exoplanet its new frontier. His enthusiasm was contagious, and he encouraged us to stay tuned for further progress in understanding our universe. The team's analysis method looked at the amount of light blocked by the planet at specific wavelengths. In doing so, they were able to gain insight into what materials are present in the atmosphere of LHS 475b. This technique involves looking for an apparent increase in size at certain wavelengths that certain molecules are known to absorb. These molecules cause more starlight to be blocked, making it appear as though the planet is larger than it actually is. The data obtained using this technique can then be used to determine which types of molecules are most abundant and what type of atmosphere might be present on LHS 475b. This helps astronomers better understand exoplanets like LHS 475b and gives us insight into how common rocky planets may actually be in our universe. The team's model analysis was essential in ruling out what wasn't present in the atmosphere of LHS 475b. By looking at the amount of light blocked by the planet at specific wavelengths, they were able to determine that it cannot have an atmosphere dominated by hydrogen or a methane-rich atmosphere like Saturn's strange moon Titan. Instead, they determined that the planet could possibly have either a thin atmosphere consisting of carbon dioxide or an atmosphere rich in carbon dioxide like Venus's. While more precise data is needed to distinguish between these two scenarios, astronomers hope to gain more clarity during an additional transit scheduled for this summer. With the Webb telescope, rocky exoplanets are becoming a new frontier for exploration and discovery. The researchers suggest that a thin atmosphere consisting of carbon dioxide could explain the amount of light blocked by LHS 475b. A thin atmosphere would produce certain features in the transmission spectrum, which is what we observe in the data. Carbon dioxide molecules absorb infrared radiation, and this absorption can explain why the planet appears to be a few hundred degrees warmer than Earth. The presence of carbon dioxide also results in a very flat, featureless transmission spectrum, which provides an excellent fit to the observations as well. Thus, it's possible that LHS 475b may possess a compact atmosphere that we're not yet sensitive enough to detect. We'll need more precise data from further transits later this year to better understand what's happening on this rocky planet. Additionally, a rich carbon dioxide atmosphere could also be the explanation for both the light blocked by LHS 475b, as well as its higher temperature. Because carbon dioxide molecules are much larger than methane molecules, they tend to block less light at certain wavelengths in comparison. This would explain why no strong absorption features were observed in the transmission spectrum. The planet's spectrum appears very flat and featureless. Additionally, a carbon dioxide-rich atmosphere may also explain why the planet is hundreds of degrees warmer than Earth. An increase in atmospheric pressure from a thicker air layer can lead to warmer temperatures on a planetary surface. One other possibility for LHS 475b is that it could be an airless body that has lost any atmosphere it once had. The lack of detectable molecules in the planet's atmosphere may hint at this possibility. Although the team could not definitively say LHS 475b is airless, they did use models to rule out more complex atmospheres. Therefore, the possibility of an airless planet remains a strong contender. However, further observations are necessary in order to confirm whether or not this is the case. Until then, we can only speculate on what secrets the mysterious rocky exoplanet holds. Due to the data collected by Webb being too precise and sensitive, it's difficult to distinguish between two scenarios about rocky planet LHS 475b. It's unclear if the atmosphere surrounding the exoplanet consists of carbon dioxide or if it has an airless body that lost its atmosphere long ago. To make this distinction, very accurate data will be needed in order to determine which scenario fits best with observations. This task became even more challenging with the lack of molecules that were abundant enough to be detected by Webb. With an additional transit scheduled for this summer, astronomers hope to gain further insight into LHS 475b's atmosphere and figure out its true nature. Astronomers are eagerly awaiting the additional transit of LHS 475b, as it'll help provide them with greater clarity about the planet's atmosphere. They hope that Webb's sensitive instruments and accurate data will enable them to distinguish between two possible scenarios: an airless body that's lost any atmosphere it once had, or a compact atmosphere too subtle to be detected yet. This extra transit could give us our first ever thorough understanding of a rocky exoplanet outside of our solar system, paving the way for further revolutionary discoveries. The James Webb Space Telescope, or Webb, has opened the door to an exciting new era of exoplanet discovery and exploration. By combining data from two transits into one transmission spectrum, researchers have been able to identify the atmosphere on a rocky planet for the first time ever. This is a major milestone in our understanding of planets beyond our solar system and demonstrates that Webb is capable of uncovering groundbreaking discoveries about distant worlds. With this powerful telescope, rocky exoplanets are indeed the new frontier in space exploration, and we can only imagine what else lies waiting to be discovered. It's clear that the Webb Space Telescope promises to revolutionize our understanding of the universe. Through its unprecedented sensitivity and precision, we now have a glimpse into the atmosphere of these distant planets, allowing us to better understand their composition and potential habitability. With Webb's help, we can finally move closer to unlocking the secrets of our universe. This is why Webb's discovery of LHS 475b is so exciting. It marks a major turning point in exoplanet exploration and opens up new possibilities for further exploration. The confirmation of this rocky planet encourages us to keep pushing boundaries, as there are surely many more undiscovered worlds out there waiting to be explored. The James Webb Space Telescope has delivered on its promise to revolutionize space exploration by revealing the presence of an atmosphere on a faraway rocky world. This incredible feat marks a significant milestone in our understanding of planets beyond our solar system and highlights the possibilities of Webb as a powerful tool for uncovering new discoveries. Let's keep pushing forward and explore what else lies beyond. What are your views on this? Let us know in the comments below.